Welcome to classes on organic chemistry. Today's class is class number 4. It is hydrocarbons and part is alkynes. It is the continuation of class number 3, and today I will complete alkyne as per the scheme of the reaction. So before starting the reaction, let me explain a bit regarding alkyne. Number 1, alkynes are unsaturated hydrocarbon. There is at least one triple bond is there. The general formula of alkyne is H twice N minus, where N starts from 2, 3, etc. The structure or hybridization of alkyne is, it is linear shaped, it is sp hybridized, hand number 1 and number 2, 1 1 2 sp3. Both the carbon is sp2 hybridized, sp hybridized. One is pi, other is pi, and one is sigma. And this hydrogen or whatever this is sigma bond and sigma bond. That is, single bond is sigma bond. When there is triple bond, 2 pi bonds and 1 sigma, and hybridization is sp. Before carbon-carbon single bond length, you should know it. Carbon-carbon double bond is, and carbon-carbon triple bond length is picometer. You should know this one. And also, in hybridization part, we have seen alkane is sp3 hybridized, alkene is, carbon of alkene is sp2, and carbon of alkyne is sp hybridized. Now you calculate the percentage of S character or P character. 3 and 1 is 4 part. Divide 100 into 4, it is 25. One part is S. 25 1 ja 25. This is 1 and this is 1, 3. Divide 100 by 3, 33.3. So S is 25, P is 75. And here S is 25, S is 2 and 3, 100 divided by 3 is equal to 33.3, S is 1 part, 33.3, and P is 66.7. S and P, 1 and 1, 2 divided by 100, 2 divided by 100 equal to 50, one part is 50, other part is 50, 50, and P is 50. These are the percentage of S and P percentage in hybridization. So now uses. Oxy-acetylene flame. Acetylene plus oxygen means ethane plus oxygen gives oxy-acetylene flame, which temperature is of about 300 degrees centigrade, and it is used as welding purpose. Number 2, acetylene is used as ripening of fruits. And third one is used as anesthetic purpose under the name cycline. These are simple uses and structural facts about acetylene. Now, preparation. In your book, there are only two preparations of acetylene. One is number 1 from calcium carbide. So how will you get calcium carbide? You see, calcium carbonate, when heated, it gives calcium oxide and carbon dioxide gas. This is limestone. And its another name is quicklime. In my first class, I gave you, when quicklime is made to react with, this gives calcium. I have not balanced it, calcium carbide, and that calcium carbide again I have not balanced. When they react, it gives calcium hydroxide plus acetylene, C2H2. This is the preparation of acetylene. Now, number 2 preparation is from vicinal dihalide. I have told you what is vicinal. CH2, Br2, CH2, Br and CH2, Br, potassium hydroxide, alcoholic, you will get this is sudamide. I also gave you at the beginning of the class. So you get this is acetylene. C2H2, its one name is ethine and common name is acetylene, and very famous name acetylene, very often used is acetylene. This is C2H2, acetylene. So this is all about the preparation up to your level or given in the text. Another preparation is, it is very important. If you want, if you can keep it in your mind, silver dust. This gives acetylene. Very often in the conversion type of reaction. This question is given. What happens when chloroform is made to react with silver dust? It gives acetylene. So this is all about preparation. The important and most attracting part of acetylene is its reaction, and it is the class is a bit above the average class. Please bear with me, because it is a combination of both NCERT and solves of entrance, so it is more than average. So I will proceed with the reaction scheme. Alkyne and a bit alkene I skipped in the third class. So first of all, alkyne. So when I talk about, I will take the first member of alkyne series CnH twice n minus 2. This is acetylene, and the first one reaction is sodium. Before going to sodium, let me explain about acidity. Acidity. So what does, when a substance is acidic, its Platonic concept is that when a substance is capable of donating one or more hydrogen as proton is called acid. The substance must contain hydrogen, and that hydrogen should easily be protonated as H plus proton. Hydrogen should be released as proton, then it is an acid. If the release of proton is fast, then the substance is a strong acid, and release is slow or weak, slow, it is called weak acid. So let us test the acidity of this one, whether it is acid. Simply if you see it, you will never think that it is an acid, but it is acid, though its acidity is low, means it is weak acidic in nature. So if you think of sp character, I have told you it is sp. In sp, s is 50%, highest percentage. In alkane, s is 25%. In alkene, s is 33.3%. In alkyne, s is 50%. So these two bonds are s and s hybridized, and due to this unit become, it is a bit tough. You just follow me. It is this part, since it is s is the highest characteristics of character of s is 50%. So due to this s, this carbon and carbon unit becomes a very smaller unit. Its bond length, I have a bit earlier I have shown you. This is picometer. Carbon single bond is 154 and carbon double bond is 134 picometer. So the lowest. So due to this lowest bond length, due to s is more, this total unit become a smaller unit. So in inorganic chapter we have seen that if a compound is smaller in structure, smaller in shape, smaller in size, its electronegativity is more. What is electronegativity? To attack the shared electron pair towards itself. The ability to attack shared electron pair towards itself is called electronegativity. So these two CC bonds are compactly packed, and due to this it has become a smaller unit, and due to this smaller unit, the unit has got greater electronegativity. So bond pair, this is bond pair, am I right? Bond pair is attracted towards this unit, and that facilitates the loss of hydrogen as proton. Hence acetylene is acidic in nature, very weak acid. Mind that very strong base of the type pseudoamide, this hydrogen may be removed. Other base cannot remove this one. Strong base is required to remove since it is a weak acid. So it is acidic in nature. So number 2, since its bond length is 134 picometer, that unit is not compact as that of acetylene. So it will not easily attract the shared electron pair towards itself and cannot facilitate the release of hydrogen as proton as acetylene shows. Also in alkane, it is again higher. P character is less, bond length is higher, 154. Again, this unit is not compact unit, hence it will not act as a more electronegative nature, hence it cannot attract the shared electron pair towards itself as acetylene does. So what is the order of reactive acidity? Order of acidity is acetylene is more acidic than ethene. This is the order of acidity. This is the order of acidity due to the reason I have explained. Next one, say you just if you remove one CH3, say C triple bond C H H CH3 H if you tell the acidity in this way, you will say here plus I effect is there. You will get in GOC plus I effect. More the plus I effect, less is the acidity, because this pumps electron and this bond pair, this unit will attract the bond pair of OH towards itself. Since it is pumping the electron towards this, so the bond pair attraction will be hampered, and more the minus I effect, sorry, plus I effect, less is the electronegativity. Am I right? So we have seen that acetylene or ethyne is acidic in nature. So this is the explanation why acetylene is acidic in nature. If acetylene is acidic in nature, then we will come to this one, sodium. Sodium is a base, it will act as a base. So what's happened? When we will make to react with sodium, then sodium will the hydrogen will be loosed as proton. Am I right? So this is plus, as it will come here. HC as plus it will. Am I right? So base and acid. It is monosodium acetinide. Acetinide. Monosodium acetinide. Monosodium acetinide. Nide or lide. You can write this is nide or LID lide. Acetylide. Both are correct. In your book it is given NID. LID is also correct. So if you made to react with other sodium, then that hydrogen will be released and here one sodium will enter. Am I right? So you will get disodium acetylide. Disodium acetylide or nide. So this is the acidity or acidic type of reaction with sodium. Number 2 is very important and it is not given in your book, but it is very important in entrance point of view, and if question is a bit tricky, that question is very often asked. Acetylene reacts with, this is cuprous chloride in ammonical solution. What's happened? That copper, it is a metal, it will be replaced by this, and again this copper will be replaced by this. So in the both part you will get in this way. I am not writing this part. Main part is this. This is red. The color is red. Dicopper acetylide. Dicopper acetylide. So this way, if you are asked to make the reaction with this ammonical chloride, cupreous chloride in ammonium chloride solution. So what is the reaction? You see, reaction will not occur here. That hydrogen is called terminal hydrogen. That hydrogen is called terminal, and that hydrogen is acidic hydrogen. This is acidic hydrogen. Am I right? That terminal hydrogen, if it is alone, will be replaced by copper. So here you will get CH3C triple bond C Cu. Again that. Now, if both sides are CH3 and if you use this one, there will be no reaction because there is no terminal hydrogen attached directly to carbon. So acidic hydrogen is not there, so no reaction will occur. Hence, this reaction is very important for the distinction of meet with propine, meet with propine and butane 2. If there is terminal hydrogen, reaction will occur, it will give red color solution, and if there is no terminal, if butane 2 butane, no terminal hydrogen is there, it will not react, no colored substance will be appear. So you can distinguish two alkyne with the help of this. So same reaction is silver ammonical silver nitrate solution, silver nitrate solution. So if there is AgNH3 holding to NO3, am I right? So here in place of copper, you will just add silver, and when silver will be there, simply I am showing you one reaction, you can understand easily. See, Sc triple bond CH acetylene NH3 holding to, am I right? There is silver, am I right? There is silver, so this is acidic, so you add up this, it is silver white PPT, silver colored, this is silver mirror, silver colored white, am I right? So disilver acetylite, it is white PPT, silvery color. But now if you use this one, no terminal acidic hydrogen is there, that reagent will not react. Again you can use in distinction of alkyne, am I right? So these two reagents are very important in distinctions of two types of alkyne, one alkyne having terminal hydrogen and other alkyne having no terminal hydrogen, am I right? So as I have shown you the reaction means if there is acidic hydrogen, then there will be reaction, and if there is no acidic hydrogen, there will be no reaction. So next type of reaction is very famous reaction, and also you know it. If you write hydrogen and if you use nickel catalyst, palladium catalyst, platinum catalyst, any catalyst, so hydrogen will go on adding, am I right? And reaction will continue, again hydrogen will add up, and it will stop when all the bonds are single, you will get ethane. So it is catalytic hydrogenation reaction, addition of hydrogen means catalytic reduction, addition of hydrogen reduction. So this is one type. So out of this, that day I have shown you, if it is CH3C triple bond in alkene, I have shown you the preparation of alkene Lindlar catalyst. If you followed this reaction, I don't know have you gone through this chapter or not. If you can't go through the earlier alkene chapter, you can't understand this one. If I use Lindlar catalyst, that is hydrogen, palladium over barium sulfate is called Lindlar catalyst, you will get cis alkene, am I right? that day I mentioned the cis alkene, and you use upon this, if you use sodium over liquid ammonia, the answer is trialkene. Sorry, trans-butane. This is 3 and this, and that reaction was big reduction. Again, it is another type of addition reaction of alkyne. So Lindlar we have done. Third question and third reaction is again very important, and it is a test for unsaturation. If there is double bond and triple bond compounds are there, this is a test. So say addition of X2, addition of X2. So we will take here bromine. So your acetylene is, this is acetylene, bromine. Am I right? So here two bromine will be get added in this way, and further another bromine will add up. So your answer will be 1 2 2 2 1 1 2 2 tetrabromoethane. Am I right? So this is the addition of halogen. The third reaction is very simple, and at the end of this one, how I will show you how it is a test of unsaturation. At the end, just you follow me, you will get it. So this is third, and this is fourth type, addition of HBr. HX. Here there is a bit problem. Say HBr, it is minus and it is plus. Am I right? So both the double bond, both the end of carbon has same number of hydrogen and hydrogen. That's why it doesn't matter in which place you will add H and which place you will add Br. So this hydrogen was earlier present, and here we will add one hydrogen, and here we will add one bromine. Am I right? Now if you add another bromine, minutely follow here, this is plus and this is minus. In my first class I told you Markovnikov addition. Am I right? So negative part will get attached to that carbon, which contains less number of hydrogen. So here double bond, on both sides double bond, two carbons, one carbon has two hydrogen and other carbon has one hydrogen. Am I right? Two hydrogen, one hydrogen. So that negative part will get attached to the carbon containing less number of hydrogen. So what you get here is bromine, bromine, H, and here H, H, and that H will be here. So that addition is called gem addition. ZEM. Gem addition means addition of halide on same carbon. Minutely follow this part, otherwise you yourself cannot add wherever you like. H is there here and Br is here. It will not be, answer will not be like this. Answer will be as given by Markovnikov. This part is a bit tricky part. So this is all about point number 4. Next one is very important, very excellently, very important in the for your board exam or NCERT exam, also in entrance exam. Very often that question is asked. So you see, minutely follow. There is a bit difficulty. HgSO4, H2SO4. Sometimes Hg is given as Hg2 plus, and sulfuric acid is given as this. And this is dilute. Dilute means there is water. water means H and OH. In presence of acid, this will break in this way. So whatever part you add in any carbon, it will not matter because both are having same number of hydrogen atom. So let me add OH in this that part and H in that part. It doesn't matter in which way you can add OH here and H here. Also, it is all the same. But that adduct is unstable. So what's happened here? That hydrogen is rearranged as this one, and bond comes in this way. This is the part you should concentrate. Otherwise, the answer will be wrong. So you are getting HC double bond O bond, hydrogen has gone here, CH3, CH3 CHO, acetaldehyde, acetaldehyde. You will never imagine that your answer will be like this. This is called isomerization, or in other word, it is if there is CH3, you see the answer will be like this. The same reagent and water is there. If you add up in this way, Hg plus and H positive, your answer will be CH3C. Now here that carbon has less number of hydrogen, OH will come here and hydrogen will go in this way. Am I right? Again, this will occur and bond will be withdrawn. Isomerization. Am I right? CH3, C double bond O, CH3. Now you see you have got acetone, propanone. Many of you will make wrong here. You will give the answer this, but that answer there will be shift of hydride. H will be go there. It is also called tautomerization, isomerization. Am I right? So this is very important type of reaction. From acetylene we may get aldehyde, we may get ketone or acetone. Its another name is acetone. Structure compound is ketone, acetone, or it is propanone. Am I right? So this is very important one. Next one is, again, this reaction is also called hydrolysis. It is done because there is acid now, it is called acid hydrolysis. Acid and HGSO4. Linear polymerization. Here two molecule of this reaction occurs in this way. One hydrogen, just you do one thing, you attach one hydrogen here, so you will get one hydrogen here, other hydrogen here, C double bond C, and you add up, ammonium chloride is there and cupreous chloride. You keep the reagent in your mind. So what's happened here, you see, you add this hydrogen here, wherever that hydrogen is added, next part is added to the opposite carbon. If you add that hydrogen here, then H2H. So one thing you see here, CH2 part is there, no? So CH2 double bond C and something that is vinyl. In my very first class, class number 1, I told you vinyl allyl. This is vinyl. So this is vinyl acetylene, monovinyl acetylene, one vinyl part, acetylene, monovinyl acetylene. If you further add another CH triple bond CH acetylene, then what will happen? And that hydrogen will be replaced. You write CH2 double bond C, C triple bond C, and here again you add CH vinyl part. Simple. One hydrogen is replaced, you will get vinyl. One hydrogen is come here, you will get CH2 CH, CH2 double bond CH is vinyl. So whenever you add this one, this is acidic hydrogen, one hydrogen left in place, again another same way another vinyl group will added. So you are getting divinyl acetylene, divinyl acetylene. So this is linear polymerization. This is linear polymerization because one unit is added in a linear fashion. That's why that polymerization is called linear polymerization. That is called linear polymerization. Now, question number 6 is again very important. Cyclic polymerization. Cyclic polymerization. Cyclic polymerization. This is very interesting. Red hot iron. Red hot iron, you will get aromatic compound benzene. So this is actually, I have not written in this way. This is actually this. You can write in this way. You can write acetylene, 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 3 acetylene. You can write 3 acetylene in this way. You can write the reaction in this way. 3 acetylene combines to give you benzene when it is passed through red hot iron. That's why it is called cyclic polymerization. So now, if you do one thing, say in one part, one methyl group is there, means this structure is actually C triple bond C H, and here one CH3 there. Meet with propyne. So 3 propyne, that will give you methyl mesitylene, MESCTYLENE, mesitylene. So that 3 part will give you benzene, and this 3 methyl will add up in this way. That will give you mesitylene. Or otherwise you can write 3 propyne, red hot iron, it will give mesitylene like this. Or you can write in this way also symbolically. This is again very important. You are getting aromatic hydrocarbon from alkyne when it is passed through red hot iron. Next one is ozone. So earlier you have seen when double bond is there, and when we made to react with ozone, then this double bond we omit that double bond in writing the ozonite. Am I right? Since there is triple bond, so what's happened here? You cannot omit this. There will be, if there is double bond, that bond should not be written in ozonite formation. Since there is triple bond, there will be one single bond carbon, and ozonite will be like this. Am I right? So now earlier it is Y-shaped when acid hydrolyzed in presence of zinc. Am I right? I explained it in detail in my class number 3. Now it will break here and it will break here. So what you get? CHO, or you can write in this way, CHO, glyoxal. That compound is called glyoxal. And this is all about the reaction of alkyne. I have given a bit more than your text. What is given in text I have given, because I structured the class to cover entrance as well as board NCERT. Am I right? So I am giving you something more on extra for entrance or for your better knowledge. So acetylene CH triple bond CH, it is acetylene. When it is made to react with chlorine, so that gives you this, and that is called, very often it is asked in the exam, Westron. And when you add, use potassium hydroxide alcoholic. What does potassium hydroxide alcoholic mean? That is, here in the structure you are getting chlorine in this way. Am I right? And I can write this one in this way, CHCl2 and CHCl2. Am I right? When potassium hydroxide alcohol, I told you, your answer will be alkene. In earlier class, I have told you it is elimination reaction. When potassium hydroxide alcohol is there, it will be this. Now let's see what's happened. Very often you can't write the answer. You see that hydrogen and that chlorine from two different carbon, one hydrogen and one chlorine, goes out. So what we get here is CCl2 double bond, CCl2 double bond CHCl2 CHCl. Am I right? CCl2 CHCl, and that is CCl2 double bond CHCl, that is called Westerson. This is Westeron and this is Westersol. Both these compounds have very important application, is that these are very good solvent for oils and fats. These are used as a solvent. In an entrance exam, very often you are given Westron and Westersol, the structure of the compound. If you do not know the parent compound and how this has occurred, and it is very impossible for you to keep the name or the formula of Westron and Westersol, you can't write it. So you know the technique, how it goes away, how elimination occurs, one hydrogen and one chlorine from here, and it gives double bond, and that answer is double bonded compound, and first one is that Westron and Westersol. Another very important compound very often asked in entrance is that same acetylene is made to react with that compound. Arsenic is there. Am I right? So you see, this is CCl2 double bond C arsenic Cl. So in place of Cl2 Cl2, and in place of that hydrogen you just put arsenic, and that compound is very important compound, and it is a gas. It is a gas and is Lewisite gas. If I want to talk about this one, it will be very lengthy class and you can't understand why it is important, because it is war gas. It is used as war gas. These are prepared by the time after First World War, America, USA, Japan, German, Russia, then Soviet Union. Am I right? And that gas cause lung erosion, and instantly it's attack upon the eyes, it's attack the skin become very reddish type, and within very few minutes or second the problem arises and people die a lot. War gas. Nowadays there is a chemical convention, this has been banned, that is Lewisites. Okay, this is a gas named after a PhD person who first gave the preparation of this one from acetylene to Lewisites. Am I right? this is about this one, about extra information of this. So another important one I have forgotten, KMNO4. Am I right? What's happened when this is made to react with KMNO4 in alkaline? Am I right? So that gives simple CH, only hydrogen 1. When hydrogen 1 is there, that become COOH. Mind that this is very important thing. I will explain later on again upon this one. One hydrogen is there upon KMNO4, that gives this one. One hydrogen COOH, one hydrogen COOH. If there is two hydrogen one, that will give you C double bond O. If there is one hydrogen COOH, if there is two hydrogen of carbon, that will give CO. In alkene, I will just explain here a bit. So this is oxalic acid. This is oxalic acid. Am I right? So this is all about alkyne or triple bonded compound. Now, very important things which I skipped due to lack of time in alkene chapter. Very easily I am showing you, say, reaction of type CH3 double bond. This number one, this is KMNO4, and this H plus. What's happened here is, already I have told you, if hydrogen, that carbon contains two CH3 group, and that carbon contains hydrogen 2. If hydrogen is, number of hydrogen is 2, then oxidation occurs very simple way. For your understanding, that becomes ketone. I have effaced out. I already a bit earlier I have written, if carbon containing, terminal carbon contains hydrogen 2, that will be ketone. That will be ketone. Am I right? 1, 2, 3. Propane 2 O. Am I right? 1, 2, 3. 2 methyl propene. 2 methyl propene. Am I right? So if you write in this way, if you are given the question in this way, see, this is 1, 2, 3, 4. But 2 in, but 2 in, but 2 in. And if you are asked what's happened when KMNO4, this is very important, I will tell you. And KMNO4 and bias reagent, I am coming bit by bit. Am I right? So a bit earlier I have told you, if the terminal hydrogen is only one hydrogen, if it is COOH, so you are getting here CH3 COOH, one terminal hydrogen here, and here you are getting CH3 COOH. Am I right? What you are getting? Twice CH3 COOH, CH3 COOH. This is oxidation of but2 KMNO4. So this is all about the extra information I have showing on alkene. Mind that this is alkene parts extra information. Extra. Am I right? So first one is KMNO4 H positive. I have shown you two reaction, very important type of reaction. Next one is Bayer's reagent. Bayer's reagent is BAYERS. Bayer's reagent is alkaline dilute KMNO4. Am I right? This is Bayer. This color is pink color. So what's happened when double bonded compound is made to react? I am showing you one reaction, and I will tell you how it is very important. It is very important. I am showing you one reaction. CH2 alkene in ethene. Bayer's reagent. BAYERS. Bayer's reagent. You will get the answer as CH2. This is glycol বা ethane 1,2 diol. This is called glycol. So fact is that when the alkene made to react with Bayer's reagent, it gives glycol and the color disappears. The color fades away. Pink color of KMnO4 Bayer's reagent will disappear. So it is a very important distinguishing test of alkene and saturated unsaturated compound. If you made to react with alkane single bonded compound with KMnO4, the color of KMnO4 pink color will remain the same. That means that it doesn't have any unsaturation. If you made to react with alkene or an unsaturated compound, so instantly it will react to give products. So during the reactions, the pink color of the reagent will disappears, vanishes. That means the compound reacting with Bayer's reagent has some unsaturation in it. So it is an important compound for test of unsaturation. So what's happened? Again, it is a very important question, very often asked. Bromine in carbon tetrachloride is given. The answer is dibromoethane. Am I right? So this is reddish orange color, the color of the bromine. Am I right? So as soon as it reacts with alkene unsaturated compound, it gives that compound that this color disappears. Again, it is a test for unsaturation. Bayer's reagents and bromine reacting with alkene is a test of unsaturation. Whenever you will make to react with alkane CH3 with bromine's carbon tetrachloride, the reddish orange color of the bromine will not disappear. That means it is saturated one. So you can very easily distinguish between saturated and unsaturated compound with the help of Bayer's reagent and with the help of bromine water. Bromine, am I right? When color disappears, it signals the unsaturation. And one of the very important reaction, very often asked in entrance exam, and I am showing you that whenever single bonded compound was there, alkane, we have shown substitution reaction. One hydrogen is replaced by one chlorine, one is substituted by other, substitution. And when alkene is there, we have seen that it gives addition reaction. Hydrogen is added, something is added, HBr is added, bromine is added, something is added, addition reaction. In alkyne, this addition reaction is there, again substitution, nucleophilic substitution is there, but I will not show you. This is a bit in high nature, but it will very easily show addition reaction. But you will surprised to see that one of the type of the reactions of when that one CH3 CH double bond CH2, it is propene. Am I right? When propene is made to react with N-bromosuccinimide, N-bromosuccinimide. What is N-bromosuccinimide? N-bromosuccinimide is this compound, N-bromosuccinimide. This is N-bromosuccinimide. When N-bromosuccinimide is made to it, that is bromine. Am I right? That bromine will be introduced in this position. Very important one, you minutely follow. Whenever you will get bromine, you will add bromine here, because already you have shown you bromine is the bromine reacts with the unsaturated compound very easily. That's why it fades away after reaction occurs. Am I right? But here, surprisingly, what's happened? One hydrogen from this is replaced by bromine. That is allylic. This part is in what class I have shown you. This is allyl. This is allyl carbon. This is allylic group. One hydrogen is removed. Am I right? So in allylic position, the one hydrogen is being replaced by that bromine. So it is allylic substitution reaction, not addition reaction. Though there is double bonded compound, double bond will remain intact. Am I right? So mind that it is free radical substitution. I will not show you the mechanism of free radical reaction, but just keep it in your mind when N-bromosuccinimide is there. That then N-bromosuccinimide, you need not to write the questions answer in this way. Just you give the answer, your answer will be okay. Am I right? So bromine when replaces, that hydrogen comes here. Am I right? Hydrogen is replaced, that hydrogen comes here. You are getting this and that. Am I right? So excellent way, double bonded compound has shown you substitution reaction in presence of N-bromosuccinimide. Another important and exciting reaction, very often asked in the entrance exam, that is again allylic concerning CH3 CH double bond CH2. This is propene. Say it is chlorine, and temperature is a very high. Again in this position, if you write in this way, there will be that is again allylic substitution. The double bond part is remain intact. It has not been touched, or there is no chlorine or any halogen is here. It is substituted by this one. So under these two conditions, very often asked in entrance exam, very high temperature and N-bromosuccess NBS. So a double bonded compound is remain intact, and in allyl position on hydrogen is being replaced by the bromine, and in another position when it is made to react with chlorine at higher temperature of 500 degrees, hydrogen from the allylic position is being replaced by the chlorine. So these are the two special type of the reaction very often asked in the entrance exam. Am I right? So at the very last, I am showing you very important 2n1 plus 2 minus n2 divided by 2 is equal to unsaturation, where n1 is equal to number of carbon, or n2 is equal to number of hydrogen. Let us see compound. Let me take this compound. It is CnH twice n. Am I right? It is alkene. Double bond is there. Now let us calculate how many double bonds are there in this structure. It is very important formula. Formula is 2n1 plus 2 minus n2 divided by 2. So let 2. n1 is number of carbon. How many number of carbon? Carbon is 6. Number of carbon is 6 plus 2 minus how many? It is 12. This is 2. So 6 to the 12. 12 minus 12 equal to 0 is equal to 2 equal to 1. There is one unsaturation, one double bond. One double bond is there. So I have shown you the way or technique how you will calculate the number of double bond in unsaturated compound with the help of the formula twice n1 plus 2 minus n2 divided by 2, where n1 is equal to number of carbon and n2 is equal to number of hydrogen. You place this number of hydrogen formula in the formula, you will get the number of unsaturation double bond is 1 or 2 or 3 double bonds are there in the structures. Very easily you can find out. So calculation of unsaturation is done by this formula. This is the end of the today's class. Thank you very much.